Hi everyone, I'm Kenicsystem, CEO of Kenicsystem. In this video, I'd like to explain the excellent concepts behind our LCD controller. The target users of our product are electronics manufacturers which need to produce small quantity lots and continue production for a long period of time. Also, OEM designers of electronic equipment will be interested in this video as well. Kenicsystem has an excellent 15-year track record in Japan. My pronunciation isn't the best, but please bear with me. When installing the LCD into your company's product, I believe you'll encounter three problems. I think the first problem is what to do about the interface between the host CPU and the LCD. In other words, this is a question of how to set up the hardware. I think the second problem is how to build the software even after the hardware setup is decided. Of course, you'd like to minimize costs such as software licenses, right? The third problem is product discontinuance. This happens when the manufacturer ceases production of the LCD, CPU, LCD controller or other part. In these cases, the problem is much more severe than the discontinuance of the capacitor and register. There is a greater impact on the PCB and software. Well, these three problems can be solved by using our LCD controller. Please allow me to explain in a little more detail. Take a look at this picture. This diagram represents the basic structure of our LCD controller. See? It's very simple, isn't it? However, do you remember seeing this somewhere before? That's right. The LCD controller for middle and small size Epson LCDs has just about the same basic structure. Even though our LCD controller has a similar structure to our competitors, we offer much better value. This is because it's a lot easier to understand and master our products. For example, most of our user manuals provide complete documentation in only 40 pages. You can finish building hardware by designing in the same way as static RAM with wait signal. So you can forget about LCD controllers with instruction manuals that are 100 number of pages long. Kenicsystem's LCD controller is used by connecting a frame buffer for image memory. From the host CPU, this seemingly appears as its own local memory. When writing some data to address number 0 of the frame buffer, a colored pixel of the data is displayed at the upper left, and when writing to address number 1 of the frame buffer, the pixel is displayed 1 pixel to the right from the upper left. It's very simple. Additionally, you don't have to consider the write timing. The bus timing allows write at any time. Thus, based on the pixel drawing function, we have a lineup of LCD controllers that executes all drawing via the software, and these controllers are low cost. We have another lineup in which the LCD controller itself carries out a box fill and photo drawing function instead of the CPU. We call this function the tiny accelerator. By using this tiny accelerator, software development is an ease. When producing equipment with LCDs, you are often afraid of the discontinuance of the LCD and LCD controller. I'm sure many viewers have experienced how often LCD specifications change. Even with Japanese manufacturers, there have been 2 changes of the driver chip in only 3 years. So how should we face this reality? To tell you the truth, externally, our LCD controller seems like a dedicated chip, but it actually contains an FPGA. Therefore, it can flexibly support a change of LCD design or a change in the driver chip. In addition, since software designed using our concept requires no OS, Even if the CPU is discontinued, porting to another one is very easy. Kenicsystem's LCD controllers can really bring down the overall cost for the entire life cycle of the product. I will demonstrate the advantage by introducing an example of the projected cost. Let's consider an example in which a medical device manufacturer introduces an LCD controller to a device that has a production number of 105 months. Check this out. I calculated the life cost of a product using the chip from a certain LCD controller manufacturer, focusing on only the LCD. Development costs for LCD part $60,000, 2 main months. Production cost for the display circuitry minus the LCD $15 by 100 pieces times 12 months times 12 years equal $216,000. 4 design changes while producing for 12 years equal $32,000. Software change cost equal $32,000. And initial cost PCV equal $20,000. As shown in this table, the total cost is $316,000. On the other hand, when using Kenicsystem's chip, development cost is same. Production cost is $18 by 100 pieces times 12 months times 12 years equal about $259,000. Design change cost $8,000. Software change cost and PCB initial cost is unnecessary. The above total is $283,000. I compare this in these tables. Therefore, even though the unit cost of the product goes up by $3, the total cost decreases greatly over the life cycle of the product. The LCD design change occurring 4 times in a span of 12 years is actually a conservative estimate. When using Kenicsystem's LCD controller, a change of the PCB and software is unnecessary. Simply customize the timing generator. And as for the initial development costs, our LCD controller is far lower, but I again used conservative numbers. Take a look again. Even so, this is the result. Of course, there are many different systems configurations, so I recommend you to consider and calculate for your own specific case. Okay, I hope you can now understand what an excellent concept we offer. I'll now briefly describe Kenicsystem's LCD controller lineup. Our LCD controller cover all small and mid-size LCDs ranging from 320 by 240 pixels to 800 by 600 pixels. And we also offer an LCD controller with a built-in LVDS. For more details, please refer to our website www.kenic.co.jp/w. Well, that's a wrap. Thanks for watching and see you later in another movie.